All right. So today we are going to start talking about translations. What is a translation? Well, in terms of transformation geometry, a translation is a slide. If we look at the triangle on the bottom right, the lighter green triangle is sliding over to where the darker green triangle is, and every single vertice slides. Likewise, with the gray one, all three slide. So B, the image of B is E, the image of C is F. And in the middle, we had the musical symbol also sliding over. So a translation is a slide. Look at it again. We have another one. And look at this yellow figure in the middle. The pre-image is what we start with. The image is what we finish with. So A becomes A prime, B becomes B prime, C becomes C prime. And that is typical notation for whenever we're dealing with transformation geometry. That prime is the image of the original letter A. So A prime is the image of A, and so on. We say that the figure we started with is the pre-image, and the figure that we finish with is the image. Notice in this third one, looks like a cashew, the arrow showing that we started with the red figure and it became the blue figure. Okay, so it slid up and to the right. All right. So we've talked a bit about translations, and of course, those are not the only kind of transformations that exist. All right. In addition to translations, we also have what we've studied prior to this, which are the rotations, the dilations, and the rotations, dilations. Dilations is what we're going to study next. I'm sorry. So here's another picture of a translation. Notice that it slides. And when we do a translation graphically, we go like walking city blocks, down and over, up and over, left and right, and so on. So we've done rotations, reflections, and now translations. And those are all what we call isometries, because they keep the size the same. Iso meaning same, metry meaning measure. They have the same measure, so they are isometries, which means the resulting figure, the image, is going to be, in each case, the same exact size and shape, of course, as the pre-image. You might be asking yourself, is it possible to create an image that's not the same size? And that's what we're going to study next. We're going to change from dealing with isometries to a type of transformation known as a dilation. Dilations shrink or grow, and the negative turns the shape 180 degrees. Think of your pupils being dilated. That means that they expand, okay? They're not reacting to light. So also when a mother gives birth, she dilates so the baby can fit through. Okay, so a dilation, usually we mean grow, but you can also shrink. Look at this funny looking penguin here. The pre-image is big, it becomes small, or in the flag of the image of the United States, small becomes big. So it can go either way. And a figure is enlarged or reduced with a dilation. Notice the small rectangle or square becomes the big rectangle or square. So that is an example of a dilation. Personal pet peeve here. I hate when students say dilation. It's D-I-L-A. That's dilate, not dilate. Okay, so it's dilation. A dilation makes things shrink or grow. They definitely change size. It's the only transformation that is not an isometry. By the way, that's often a quiz or a test question. Which of the following transformations is not an isometry? And they'll give you reflection, rotation, translation, dilation. The answer to one that is not an isometry is a dilation. Remember, isometry means same size and shape, and a dilation does not keep the same size. All right. I'm actually overdubbing this on a video that I'm following up on to make bigger. So sometimes the timing is a little bit off. Here we have in the upper left the center of dilation, and look at the figure, the triangle whose sides were 4, 6, and 8. it now becomes 8, 16, and 12. So the 4 becomes 8, the 6 becomes 12, the 8 becomes 16. Everything is doubled. So that dilation is dilated by a factor of 2. Notice in the one on the bottom right, the blue is the pre-image, the green is the image. It's getting smaller. And that's what happens when the scale factor is between 0 and 1. So if it's like a half, it gets half as big, and half as big means smaller. So the bottom right is a picture of dilating by a factor less than 1. Here's 2 more examples to bring that point home. First, a scale factor of 2. Notice the pre-image A becomes A prime, it gets twice as big. On the other hand, if I do a scale factor of a half, the big triangle A becomes much smaller, A prime. So scale factor greater than 1 increases the size. Scale factor less than 1 decreases the size. Here you have it again, a dilation with the pre-image, the blue, I guess they're squares, becoming the yellow or gold or russet square. Notice it's getting bigger, so that would have a scale factor greater than 1. And as we mentioned before, with the example of the blue to green, that is a factor between 0 and 1. It can't be less than 0 because that would rotate it also 180 degrees or reflect it 180 degrees. So that is definitely not going to be a negative because it's staying in the same line with the center of the dilation. Okay? So just remember, dilation, greater than 1 it grows, less than 1 it shrinks. Greater than 1 it grows, less than 1 it shrinks. Kind of easy to remember, greater and grows. So here, if we start with what's going to be the blue parallelogram in the middle, and it becomes the yellow parallelogram, that's growing, it's getting bigger. What would you know about that scale factor? Well, has to be greater than 1. And check it out. A prime, oh, I'm sorry, take it back. We started with the yellow triangle. We became the blue triangle. In the yellow triangle, it was 2, 4. Then it became 1, 2. So that scale factor is a half. So here we go. All 4 types of transformations. Translation slides it. Reflection flips it. Rotation spins it. Dilation grows or shrinks it. The only one that is not an isometry is a dilation. The only one not an isometry is a dilation. That's a really good summary of all the different types that you have. Now we go into what we call tessellations. With a tessellation, there is no overlap or space, and it is a repetition of shapes or tiles. Okay, so tessellations tend to make patterns, no overlaps or spaces, and repetition of shapes or tiles. And they all kind of fit together with no spaces in between and no overlaps. They can make nice wallpaper, Christmas wrapping paper, and so on and so forth. So here is you can see your example of a tessellation here with a bunch of leaves in autumn that are falling down. And I'm sure we have a few more nice tessellations for you to get a picture of before we end our session for today. Okay. Or I should say this session for now. Okay. I don't know what else I would have been saying in the original video. I apologize. But unfortunately, we needed to clean up that audio a little bit. So that's why I'm doing this now. And I'm waiting for the next slide so I can talk a little bit more about tessellations. And tessellations are not the most important thing in the course, that's for sure. We just ask that you're able to recognize them when you see them. And what are you looking for? Again, what it says here, no overlaps or spaces, and no, it's a repetition of a shape, in this case the tiles. It happens over and over and over again with no overlaps or spaces in between. That is a tessellation. Okay? Think wallpaper, think tablecloth, think book cover, think anything like that. So here we have a tessellation, and it doesn't only have to be one shape. There's triangles and squares here, okay? So let's make that perfectly clear. It's a repetition of shapes, Not necessarily one shape done over again, like the other one was a leaf that repeated its pattern. This time it was a square and a bunch of triangles, and now we've got like one-way arrow symbols, but we changed the direction that they go on, and so on. We have square parallelograms, rhombus actually on the left and on the right, very Escher-like design. We have birds, whether you see the white bird or the black bird that's going through there. So we have spoken about geometry transformations with rotations, reflections, dilations, translations. Which one of those is the only one that is not an isometry? Dun, dun. Let's make it official, like Jeopardy. Do 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 up. Da na 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 na. Dun da na 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 na. The only one that is not an isometry is a dilation. All right, on to the next video. Have a great one.